Welcome to MACH 161 Metallurgy. In this class, we are going to be studying the properties of materials. Mainly, but not exclusively, metals. Ferrous and non-ferrous metals. The text you'll be needing will be Metallurgy Fundamentals by Daniel Brandt and J.C. Warner. Metallurgy. Formal study of materials that we use to make things, mainly out of metal. A person has to know their material's limitations, what that material can do and what it cannot do. We can overcome materials' limitations by design or materials improvement. Knowledge of these properties helps you choose the correct material for the right job. Why is that important? Civilizations are often divided into ages, according to the ability to dominate materials in the society. The Stone Age. Basically, tools and weapons were made of stone. The Bronze Age is the time period when people made tools from an alloy. And remember, an alloy is a mixture of metals. The alloy that they used was bronze. That's why they called it the Bronze Age. Makes sense, doesn't it? Bronze is a mixture mainly of copper and tin. Usually 9 parts copper to 1 part tin. Materials like wood and stone were also used for tools, but bronze was much better for cutting and chopping, and was easy to shape. The Iron Age. The final technological and cultural age in the Stone, Bronze, Iron Age sequence. The date of the full Iron Age, in which this metal was most part replaced bronze in implements and weapons, varied geographically. Beginning in the Middle East and southeastern Europe, about 1200 BCE, but in China, not until about 600 BCE. Although in the Middle East, iron had limited use as a scarce and precious metal as early as 3000 BCE. There is no indication that the people at that time recognized its superior qualities over those of bronze. Between 1200 and 1000 BCE, however, the export of knowledge of iron metallurgy and of iron objects was rapid and widespread. With the large-scale production of iron implements came new patterns of more permanent settlement. On the other hand, utilization of iron for weapons put arms in the hands of the masses for the first time, and set off a series of large-scale movements of peoples that did not end for 2,000 years, and changed the face of Europe and Asia. The Plastics Age. Within the last few decades, plastics has revolutionized our daily lives. Globally, we use in excess of 260 million tons of plastic per year, accounting for approximately 8% of the world oil production. Whether you knew it or not, plastic is made from petroleum. The Silicon Age. This is our current period in time. The previous historical age periods were the Stone Age, the Bronze Age, the Iron Age. The Silicon Age is also called the Age of Information. Take a look at the fuselage on this Boeing 737 aircraft. Looks like it's Hawaiian Airlines, and the whole top, right behind the cockpit, has been ripped off. What do you think could have caused this? Pilot error? Terrorism? Did somebody blow off a bomb in the front there? Hard to tell, because if it was a bomb, I don't think it would be such a clean break in the material. Mechanical failure? Probably. Let's look a little farther at the next slide. If you guessed mechanical failure, you were correct. Metal fatigue. So the metal, the aluminum shell around here had failed, and it ripped off mid-flight. 737-200 Boeing aircraft with 89.090 flight cycles. The whole top of that fuselage was destroyed. Look at the people still sitting in their seats. Not sure what happened to these folks here. I'm hoping that that's these people here, or that's them sliding down the inflatable slide. But this happened in 1988, and pretty scary deal for those folks. It really drives home the importance of metallurgy. In this example, these two gentlemen flying through the air, and all of a sudden their propeller just split, sending them, not sure exactly how they crashed. They could have landed it and just ended up on the nose, but another example of making sure that the materials are able to withstand its limitations. And you can see here that the impeller here split off and did not bend, meaning that it was fragile and possibly processed incorrectly. A little different scenario with this aircraft. As you look at these propellers over here on the left side of the aircraft, you can see that the fins on the aircraft actually bent. So when it hit the ground here, they bent instead of snapping off. It's interesting that these ones bent and these ones remain straight. So what that tells me is actually they didn't bend from hitting the ground, but in flight, either this engine was spinning too fast. I'm not sure exactly what happened, but had a catastrophic failure in the air, and these fins on this propeller bent, causing the aircraft to crash. And these pilots did survive this crash also. So, we must know the limitations of a material in order to fabricate safe and reliable products. We want to be sure that that car we're driving is going to stop when we need to stop, go when we need it to go. When we're flying in that aircraft, we want to be sure that it takes off safely, flies us in that metal tube through the air, and gets us to our destination safely. When a part fails prematurely, the remedy is to improve the part by a design change. Some design changes, we could add mass to reinforce the weak areas. The only issue with adding mass is we also add weight. We could increase the lubrication. We could cool the moving parts. We could add protective coatings, such as anodize, powder coating. We could also improve the part by a material change. There are stronger, more flexible, lighter, high temp resistance, corrosion resistance materials that we could use. The things that we have to keep in consideration is weight, toughness, brittleness, making sure the material will be able to withstand the forces that we're going to put on it. Here's another example of a catastrophic failure of a mechanical part. You can see right here, this wheel has separated from that fork. And I believe that this is all the fork oil just pouring out of this fork right here. And I'm not sure exactly what happened, but obviously the operator was pushing this piece of equipment farther than its design limitations was meant to be handled. And the classic look of the driver's face. It's like, uh-oh, I wish I would have worn my helmet. Let's see what Clint Eastwood has to say about this. Man's got to know his limitations.